Okay, so hey, how are you? Excuse me, good day. Today, the topic is solving linear equations or the search for x. So, like, sort of on a treasure hunt, trying to find out what x is or whatever variable it is that we're searching for. So, that's where we go. So, we don't want you to find x this way. Don't give us one of these where we go find x. Oh, there it is. That's not what we're talking about. We're talking about actually solving equations. So, as we move towards solving equations, start with this little equation right here. 5 plus 3 is equal to 8. True? True. If I add 2 to this side, is it still a true equation? 5 plus 3 is equal to 8 plus 2? No. In order to make it a true equation, I have to add 2 to the other side. So now it's 2 plus 5 plus 3 is equal to 8 plus 2. Both of them are equal to 10. We're good. Okay? If I start with 5 plus 3 equals 8, can I subtract 3 from this side? No, I can't. Okay, if I subtract 3 from this side, I've got to subtract the 3 from that side. So negative 3 plus all that. If I do that, negative 3 plus 5, plus 5 plus 3 turns out to be the same as 8 minus 3. Okay? So the point is, what I do to one side happens to one side has to happen to the other. Okay, this isn't like what happens in Vegas stays in Vegas. What happens on one side, what happens to one side has to happen to the other. Okay? I don't know if I just made that up, but sort of like the scale. So we've got to keep things balanced. So it's sometimes referred to as balancing equations or something like that. So we want to keep the scales balanced. But what happens to one side has to happen to the other. If we add 2, we've got to add 2 to the other side, subtract 3, multiply by whatever. Okay, there we go. So this video is set up in 4 different parts. Okay, part 1 is just one-step equations. Part 2, two-step equations. Part 3, variables on both sides of the equation. Part 4, the multi-step, multivariable with parentheses. So what I've done is I put this little card up in the corner of each section. So for section 1, you see an ace, and then a 2, and then a 3, and then a 4. As you're looking through a video, if you start with one-step equations, you go, get this, fast forward to the two-step equations. Okay, if you go, oh, I get this, fast forward to part 3. Okay, and the way to be able to tell where you fast forward to is when you see a different card up in the corner. It's up here. You'll see when we get going. Okay, our goal is that everyone's able to solve linear equations like these with variables on both sides. But if you're already there, then we want to challenge you and have you move towards that multi-step, multivariable principle. So take your time, and if you get to a place where you've done part 1 and part 2 and you feel like, hey, let me try this for a while before I see part 3, come back, see part 3 later. Okay, our goal over the next couple of days is to get everybody to be able to do this and to challenge ourselves with part 4. Okay, so here we go with part 1, one-step equations. So when we're looking at something like a one-step equation, it means because there's one step to get to the solution. Okay, some number, x, plus 7 is equal to 12. And a lot of times we can look at this and go, oh, what number plus 7 is equal to 12? That's really what it's asking. So hopefully the answer that jumps out is 5. 5 plus 7 is 12. Okay, mathematically what we're doing, and just trying to get through the process, is we're subtracting 7 from both sides. If I do 7 minus 7, that turns out to be 0, so I'm just left with x equals 12 minus 7 is 5. Okay? I know you guys like to do that. Oh, let me draw the line down the middle. If you want to do that, do it. I don't, so I'm not going to start. Okay? All right, it's not that I don't like it. I just don't do it. Okay? X equals 5. One step. Boom, we're there. Okay? Similarly, if the equation's like x minus 4 is equal to 8, we're saying what number, when we subtract 4 from it, gets us 8. And the way to do that, the way to get to that answer is, well, we're going to undo the subtract. We took a number, we subtracted 4, we got 8. So we're going to undo that step. The way to undo subtraction is to add. So I'm going to add 4 to both sides. That makes that 0, so I get x equals 12. One step, and we're done. I like putting a box around the answer. That helps. It helps to stand out. There's the answer. Okay? Here. 4 times x equals 100. 4 times some number equals 100. 4 times what number equals 100? That's the question. So we took a number, we multiplied it by 4. We got 100. So in order to undo that, we're going to divide. The way to undo multiplication is with division. So we divide both sides by 4. 4 divided by 4 is 1. So we're just left with 1x, and we never really write a 1 in front of it, equals whatever 100 divided by 4 is, and I think that's 25. Box around it. Done. Okay? So this is probably the most difficult one-stepper. Some number divided by 5 is equal to 16. So to undo the dividing by 5, we have to do the opposite. We have to multiply by 5. So multiply by 5, multiply by 5. 5 divided by 5 is 1, so we're left with just x. And then we have to go through and figure out what 16 times 5 is. I tell you, it's 80. Okay? One-step equation, so there's one step and we're there. Okay? So that's the way to start. Then we get into just two-step equations. Okay? Two-step equations, oddly enough, they have two steps. So remember order of operations, when we're doing something, we proceed in this order. So doing. With these sorts of things, what we're doing is we're undoing. We're undoing what was done. So we do our order of operations in reverse. We deal with our addition and subtraction as a first operation, then we deal with the multiplication and division. So just remember, do the opposite order of operations when we're undoing. Okay, so I've got 3x plus 5 equals 17. Okay, I took some number, multiplied it by 3, and then I added 5, and I ended up with 17. Okay, so what we want to do is we want to undo that. So we started with a number, we multiplied it by 3, and then we added 5. Okay, added 5. That's my little coding, I like to call it. So to undo that, we work in the opposite direction. Okay, so first we're going to subtract 5, and then we're going to divide by 3. So just as we have a little road map, so first step, subtract 5. Okay, 17 minus 5 is 12. That leaves me with only 3x on this side, as the 5s are gone, and then we're back to a one-step problem. Divide by 3, x equals 4. Okay, so the two-step problems are just like the one-step problems, except just two steps. Okay, so again, we started with some number x, we multiplied it by 4, and then we subtracted 3. That's what we did. That's what we did. So to undo that, to work in the other direction, we're going to, I don't know what that is, we're going to add 3, and then we're going to divide by 4. So working in the other order. So adding 3 to both sides, it's the opposite operation of subtraction, gives me 4x equals 24. Divide, that's the next thing we said we were going to do, divide. Zing, zang, zung. Done. Okay? Two-step equations, order of operations. If you like this coding stuff, it's a good thing to do. Look where x is, what's being done to the x, we want to undo it. Undo what was done. That's our whole plan. Okay? Another one of these. All right, so this may be the more difficult one. So we started with x. Right there. We divided it by 4, and then we added 5, and we ended up with 8. So if we're going to work backwards, first thing we're going to do is subtract 5, and then we're going to multiply by 4. It's the opposite order. So subtracting 5 from both sides, subtract 5 from both sides. We get x divided by 4 equals 3. Okay, and we're back to that what number divided by 4 equals 3. So our rules say we're going to multiply by 4, 4 divided by 4, x equals 12. All right? Oh, well, this is just a little slightly different variation as we work through this one. So we started with x. We multiplied it by -3, okay? And then we're adding 5. This is a plus 5 here, okay? We're adding 5. There's no sign there, so it's plus. So that's the done, the undone, subtract 5, divide by -3, okay? So let's subtract the 5, leaves me with -3x equals 15. Divide by -3, divide by -3, remember, doing to both sides, x equals -5, okay? And the beautiful part about all these, and I haven't been doing it, is you can check your answers on all of these. You can just, to make sure that you got an answer right. If you're not sure, you want to make sure it seems reasonable. 5 minus 3 times -5 equals 20, okay? 5 minus -15 equals 20. It seems like that's 5 plus 15. Seems like that's 20. It's 20, so we can check them. We don't need to, but if you're not sure. And now on to part 3. This is where we all need to be eventually. Part 3, variables on both sides of the equation, like this. We've got variables on both sides. So the idea, I always say, is to get the letters on one side and the numbers on the other. And the way we do that is we just add and subtract as our heart's content to make sure that we get what we need. So when we're starting a problem like this, there's like 4 different things we could do. But our goal would be to get the letters on one side, numbers on the other. And, you know, if you want to be specific, try to get the letters on the left and the numbers on the right. Don't really matter to me, but I would do that. So since this is letters and it's on the right-hand side, I'm going to get rid of it. I'm going to subtract 3x. Okay, so that's all gone. So then I'm left with 5 minus 3, I think is 2x, plus 2. All that's left over here is the 10. And then I'm back to a 2-step problem. Okay, and we can all work it from there. Subtract the 2, 2x equals 8, divide x equals 4. Okay, like that. Okay, we can check it out. On this side I get 5 times 3 is 20, plus 2 is 22. On that side I get 3 times 4 is 12, plus 10 is 22. Ta-da! Okay, letters on one side, numbers on the other. There's like 4 different things we could have done. I tend to just move the x's if I can. Okay, another problem like that. Letters on one side, numbers on the other. Well, let's move that 2x. Move the 2x. Okay, so that leaves me with 3x minus 2x is 1x, and we don't tend to write the 1. It's a little lazy mathematician sort of thing. Left with a simple real one-step equation at this point. Some number minus 7 equals 8. Add 7 to both sides. Add 7 to both sides. X equals 15. There you are. Okay. Check it out. 3 times 15 is 45. 45 minus 7 is 38. 2 times 15 is 30. 30 plus 8 is 38. It works out. It checks. Check. Okay? That's the sort of problems that we're looking at everybody being able to do, because we need to be able to do those as we move forward into systems of equations and other things like that. It's kind of that next level from just 2-step equations. All right, so this one, is this the last one in part 3? Yeah, so would I leave that one for you to try? I think I should. It's got some extra things going on, but I'm going to leave that one for you to give it a shot, and we'll see where we are in the morning on that one. So when you come in tomorrow, you can let me know if you get whenever you get to part 3. We'll take a look at that one. Okay. So multi-step, variables on both sides, parentheses, just pure craziness in terms of a problem. Okay, this is part 4. This is the stuff that, you know, if you want to challenge yourself, you need to challenge yourself. We don't want you to be bored, so we go with it. Okay. So the first thing we're going to do is we're going to probably distribute. We're going to deal with our parentheses, try to make our equation into some nicer looking form. So when I distribute, I get 5x minus 10. If I didn't change anything, I'm just going to write it again. 4x plus 6 equals 2x, and now distribute again, plus 3x plus 6. Okay? So I've got a lot of x's on here, so I'm going to try to make it so I don't have as many things going on. 5 plus 4 is 9. 9x. Negative 10 plus 6 is, I think, negative 4. Okay? On this side, I've got 5x plus 6. Okay? So then, I'm back to a 2-step, you know, variables on both sides sort of deal. I just continue from here, subtract 5x from both sides. I'm left with, what, 4x minus 4 equals 6. Then I'm back to a 2-step equation. Add 4 to both sides, add 4 to both sides. I end up with 4x equals 10. Okay, and then I'm going to just divide by 4. Divide by 4. Those are gone. X equals 10/4. Okay, which is 5/2. Okay, and you're probably going, no, 5/2 can't be an answer. That's not possible. How could we ever have 5/2 of anything? You'd have 2.5 somethings, right? That's all 5/2 is. It's perfectly fine if our numbers don't come out to be a nice whole number. Sometimes that'll happen in the world where things aren't exactly everything in wholes. You know, sometimes you put 2.5 cups of flour in something, which would use 5. I would use the half cup 5 times because I'm too lazy to wash that many dishes. But anyway, don't worry about it. If you've done the work, if you take your time, you go through the steps, you know what you're doing, doesn't matter what the answer turns out to be. Okay? And then there's, I think, this one, right? Yeah, so let's do this one together just for the fun and merriment of it. Distributed would be the first thing, 4x minus 12. Okay, here's where it's going to be a little tricky. We're going to be distributing really a negative 2 in here. Negative 2 times 4 is negative 8. Negative 2 times negative 2x is plus 4x. And then on this side, we just have 3x plus 7. Let's see what we've got together. I've got 8x minus 20, negative 12 minus 8 more, is equal to 3x plus 7. Back to the thing on with variables on both sides. Subtract 3x, zing, 5x minus 20 equals 7. Add 20, we get 5x equals 27. Divide by 5. It's 5 apparently. Bing. So x equals 27 fifths. Not a delightful answer, you might think, but it's a good answer. You know, we could work our way back through and make sure that it all turns out to be copacetic, but it's fine, okay? Notice I'm showing a lot of work as I go through this. I expect you to show a lot of work as you go through these problems. We expect everyone to show work so that way we can see, whoops, geez, you added negative 12 and 8 wrong. You put plus 20, but it doesn't mean you don't know what you're doing. So the more work you show, the better off we are. You know, if we want to get into credit, partial credit and whatnot, then we want to be able to see that. But I really want to see what you're thinking, and that's what writing work down shows me, what you're thinking. Okay, I think that's about all for this moment. Okay, if you've made it to part 4 and you're willing to work on some of those part 4 ones, congratulations. If not, we'll get you there. Ooh, went a little long. That's okay. You're going to watch this in parts. So, hope you learned something. If there's questions, you know to ask. Thanks.